It's time for Math with Mr. Young. Lesson 104, Semicircles, Arcs, and Sectors. Let's begin with a PowerUp. You can use the worksheet provided, or simply pause the video and use a blank sheet of notebook paper to answer the problems on your screen. Go ahead and pause now, and resume once you've completed all of the problems in this PowerUp. In this PowerUp, we get to review adding, subtracting, multiplying, and dividing numbers and variables. First, we have 6x plus 2x. To solve expressions like these with variables, the way I try to make sense of it is to put something concrete in place of the variable at first. So instead of saying x, I'd give it some concrete value. Let's imagine that x is an inch. If we had 6 inches plus 2 inches, that would be easy, correct? It would just be 8 inches. So 6x's plus 2x's is also easy. It's just 8x's, or 8x. And there's your answer. This next problem is just as easy as before. 6x minus 2x. Let's imagine something concrete for this variable. This time, maybe x is a foot. 6 feet minus 2 feet would be easy, right? It's just 4 feet. So 6x minus 2x is 4x. And that's the answer. Our next problem has 6x times 2x. For this kind of problem, it also helps to think concretely first. Let's imagine that x means centimeter this time. So I start with 6 centimeters. If I were to double my 6 centimeters, I would have 12 centimeters. So 6 centimeters times 2 would be 12 centimeters. That means that 6x times 2 would be 12x. But that's not what the problem says, is it? In the problem, we're not just multiplying by 2, which would mean doubling, we're multiplying by 2x. So we can't just think of 6 centimeters multiplied by 2, we need to think of 6 centimeters multiplied by 2 centimeters. Can you think of anything that is measured 6 centimeters by 2 centimeters? How about a rectangle that is 6 centimeters long and 2 centimeters wide? To find the area of this rectangle, you'd multiply the 6 centimeters by the 2 centimeters. And what's the result? Our result is 12 centimeters squared. 6 centimeters times 2 centimeters is 12 centimeters squared. So our 6x times 2x must be 12x squared. There's our answer. The next problem features division. 6x divided by 2x. To solve this one, I want you to remember that whenever you have something in the numerator and the denominator, they cancel out. Here we see x in the numerator and in the denominator, so we can simply cancel those two x's. That leaves us with 6 over 2. You can solve 6 over 2, can't you? 6 divided by 2 is 3. Our answer is 3. Our next problems will be similar to these first 4, but they will now have more variables. This won't change how we solve them. Up first, we have 9xy plus 3xy. Remember that adding 9 something plus 3 of that same something just gives us 12 something. So 9xy plus 3xy will give us 12 xy. Pretty easy, right? Our next problem trades addition for subtraction. 9xy minus 3xy. Again, 9 of something minus 3 of something would simply be 6 of that something. So 9xy minus 3xy will simply be 6xy. That's the answer. Now we have multiplication again. 9xy times 3xy. This time, I'm going to show you a shortcut on how to solve this. You can think of 9xy as being 9 times x times y. So write it that way. You can also think of 3xy as being 3 times x times y. Write it out that way as well. Now, using the commutative property of multiplication, which is just a fancy way of saying that you can move the numbers and variables around, let's group the constants together and the different variables together. 9 times x times y times 3 times x times y becomes 9 times 3 times x times y times y. Remember, any number multiplied by itself is that number squared. So x times x here is x squared. The same thing goes for this y times y. That is y squared. So now all we have left is 9 times 3, which is 27. So our answer is 27 x squared y squared. Nice job. Now we have division again. 9xy over 3xy. Just like our last division problem, let's cancel. X on top cancels with x on bottom. Y on top cancels with y on bottom. That leaves us with 9 over 3. 9 divided by 3 is 3. That's our answer. Next up, we have x plus y plus x. To figure out how we're supposed to solve, let's imagine something concrete for our variables again. Let's imagine that this x is a foot and this y is an inch. If this problem was a foot plus an inch plus another foot, it would be pretty easy to find the answer. The answer would be 2 feet and 1 inch. Something to notice here is that simply saying a foot or an inch is the same thing as saying 1 foot or 1 inch. A foot plus an inch plus a foot is the same thing as saying 1 foot plus 1 inch plus 1 foot, which is why our answer is 2 feet and 1 inch. Let's apply this to our problem. X plus y plus x is the same as 1x plus 1y plus 1x. 1x and 1x can combine, just like 1 foot and 1 foot combined. It becomes 2x. So our answer is 2x plus 1y, or simply 2x plus y. Our next problem is similar, but has subtraction in it. X plus y minus x. Once again, let's imagine this problem with feet and inches. A foot plus an inch minus a foot would be what? Well, let's put in our implied ones. This problem wouldn't change if we said 1 foot plus 1 inch minus 1 foot. What's 1 foot minus 1 foot? 0 feet. So our answer would be 0 feet plus 1 inch. You don't have to say the 0 feet part, so we can erase that. Our answer is simply an inch. Now, let's go back to our problem. First, add in the implied ones. 1x plus 1y minus 1x. Subtract this 1x from this 1x. 1 minus 1 is 0. So our answer is 0x plus 1y. We can simplify this to 1y, or just y. Now, on to multiplication again. X times y times negative x. Remember a previous lesson where we learned about multiplying negatives. When multiplying a bunch of numbers or variables together that include negatives, first do the multiplying and worry about figuring out whether the product is positive or negative at the end. Here we have x times y times x. X times x can become x squared. So our product is x squared times y, or x squared y. Now, should our answer be positive or negative? Well, if the number of negatives being multiplied together is odd, then our answer must be negative. And we have one negative, which is an odd number. So this answer will be negative x squared y. Now, on to division. X times y over x. Hopefully you remember that, to solve this kind of problem, we can cancel. The x on top and the x on bottom cancel each other out. We're left with just the one y on top. So our answer is y. Way to go! Now the problems get a little bit trickier. Up first, we have 3x plus 3. To solve this one, I want you to think about what you learned in a previous lesson about like terms. Do you see any like terms here? Remember, like terms are terms with the same variable part. The variable part of 3x is x. The variable part of this x, which is also 1x, is x also. So these are like terms, and we can combine them. 3 of something plus 1 of that same something is 4 somethings, so 3x and 1x combine to become 4x. We can't do anything to simplify this 3, so we just leave it as is. Our final answer is 4x plus 3. This next problem with subtraction works the same way. 3x minus x minus 3. Once again, find the like terms. 3x and x are the like terms, just like in our previous problem. This time, the problem is asking us to subtract 1x from 3x. 3 minus 1 is 2, so 3x minus 1x is 2x. Once again, we leave this constant as is, and so our final answer is 2x minus 3. Now multiplication. 3x times negative x times negative 3. We're multiplying negatives again, so do the multiplication part first, and we'll worry about whether the answer is positive or negative at the end. Something to remember here is that when we're multiplying, you might want to write out 3x as 3 times x. So, disregarding the negatives for now, we have 3 times x times 3. Hopefully you remember that this x times x can become x squared. Now we multiply this 3 times 3 to get 9. So far, we have 9x squared. Let's see if our answer is supposed to be positive or negative. Back here in the problem, we had a negative here and a negative here. That's 2 negatives, which is an even number. That means our answer is going to be positive. So our answer is positive 9x squared. Finally, we have 2x times 8xy over 4y. For this problem, which has multiplication and division, it will help you to write out 2x, 8xy, and 4y in this way. 2x becomes 2 times x. 8xy becomes 8 times x times y. And 4y becomes 4 times y. Now, let's use the commutative property to do a little rearranging. Let's group the constants together up top. Let's also bring the x's next to each other. So now our problem reads 2 times 8 times x times y over 4 times y. Let's first multiply this 2 and 8 together to simplify that part. 2 times 8 is 16. Now, notice that there is a y on top and a y on bottom. Those y's cancel out. Also, we can pull a 4 out of the top and the bottom. 16 divided by 4 is 4, and the 4 on the bottom divided by 4 is 1. So 16 over 4 simplified to 4 over 1. Now we have 4 times x on top, and 1 on the bottom. We don't need the denominator anymore, because anything divided by 1 is just itself. So now we have 4 times x times x. X times x becomes x squared. That leaves 4x squared. That's it, we did it. Now, pull out your notes page. Today we're learning about semicircles, arcs, and sectors. So, to start, I want us to remember the formula for both the circumference and area of a regular circle. The circumference of a circle is the distance all the way around the circle. That distance is equal to the length of the diameter, which is the line that goes through the center of the circle, times pi. Pi is a number that is a little bit bigger than 3. So that means that the distance all the way around a circle is a little bit more than 3 times the length of the diameter. So one way of writing the formula for the circumference is pi times the diameter, or pi d. However, because the diameter is the length of 2 radii, the radius being the distance from the center of the circle to the edge, then we can also write the formula for the circumference as the radius times 2 times pi. According to the commutative property, the order of this 2, this pi, and this r doesn't matter, so we can switch them around to get 2 times pi times r, which is usually how it's stated. The circumference of a circle is 2 pi r, or pi d. Now, remember the formula for the area of a circle. Remember, area is two-dimensional, so our units will always be squared. We should also expect then that our formula will have a squared in it, and it does. The formula for the area of a circle is the radius squared times pi. Using that commutative property once again, it can be written as pi times r squared, or pi r squared. The area of a circle is pi r squared. Knowing these formulas, we should be able to figure out the formula for a semicircle. But first, let's define a semicircle in our notes. A semicircle is half a circle. That was easy. So if a semicircle is exactly half of a circle, we should be able to figure out the formulas for a semicircle by taking our circle formulas and dividing them in half. To find the formula for the area of a semicircle, for instance, just take this formula for the area of a circle and divide it by 2. We have pi r squared over 2. That's it. Similarly, to find the length of the distance from here to here, which is halfway around an entire circle, we take the formula for the circumference of a circle and divide by 2. 2 pi r over 2. These 2's cancel, so the formula is just pi times r. Let's check to make sure we understand this by doing an example problem. Find the perimeter of this figure. Use 3.14 as an approximation of pi. So how do we solve? First, remember that perimeter means the distance all the way around the figure. Part of that answer is already given to us here. The distance across the bottom of the figure is 4 inches. Now we need to add that length to the distance it takes to travel around the semicircle, from here all the way to here. Because a semicircle is exactly half of a circle, we know that the distance from here to here is exactly half of what would be the entire circumference of a circle. The formula for the circumference of a full circle was pi times the diameter. So the distance around this semicircle would be half of that. Dividing the diameter by 2 gives us 2 inches. Now let's multiply that by 3.14. 3.14 times 2 is 6.28. The distance from here to here is approximately 6.28 inches. Now, don't forget to add this distance we just found to the length of our diameter. Adding those two together will give us the perimeter of our figure. 6.28 inches plus 4 inches is 10.28 inches. That's our answer. Well done. Now, let's go back to our notes and add 2 more definitions. First, an arc. An arc is the distance around a portion of a circle. Go ahead and draw a circle in your notes. And then use 2 points to indicate a segment of the circle. This portion of the circumference of the circle from here to here would be an arc. Next, let's define sector. A sector is a portion of a circle bound by 2 radii and an arc. What does that mean? Again, let's draw a circle in our notes. Now, just like last time, draw 2 points, creating an arc. Now, draw lines connecting those points on the edge of the circle to the circle's center. This line is a radius, and this line is another radius. Now we have sectioned off a portion of the circle which lies between the 2 radii and our arc. That portion of the circle is a sector. Did you know that a semicircle is also a sector? Take a look at this semicircle. Now, imagine that the rest of the circle is there too. From this point to this point is an arc. And if we draw radii, which are the lines connecting these points on the edge of the circle to the center, we see that we've sectioned off exactly half of the circle. So a semicircle is a sector equal to 1/2 of the circle. That means its area is 1/2 of the circle's area. And the length of this arc is 1/2 of the circle's circumference. So think about that for a second. If a semicircle is a sector that is 1/2 of the circle, and that made its formulas 1/2 of our normal circle formulas, then let's see if you can guess what the formulas for this sector would be. Hopefully you guessed our normal circle formulas divided by 4. The length of this arc will be 2 pi r the formula for circumference, over 4. The area of the entire sector will be pi r squared, the formula for the area of the whole circle, divided by 4. So, our last example will be this. Consider a sector of a circle between these two radii. The angle formed at the vertex of the two radii is 30 degrees. The radii are each 4 inches long. Find the area of the sector and the length of arc A. Leave pi as pi. So, how do we solve? Well, when we needed the formulas for a quarter circle, we took our regular circle formulas and divided by 4. When we needed the formulas for a semicircle, we took the regular circle formulas and divided in half. What do we divide our regular circle formulas by to find this portion of the circle, though? Well, we just need to know what percent of the total circle is shown here. And we can find that out from the degrees of this angle, which is also the degrees of this arc. To find out what percent of the circle this is, first remember how many degrees are in a full circle. This angle would be 0 degrees. This is 90 degrees. This is 180 degrees, and all the way around is 360 degrees. So if a whole circle is 360 degrees, and we have 30 degrees, what portion of the circle do we have? We have 30 over 360, which reduces to 3 over 36, and finally to 1 over 12. We have 1/12 of a full circle here. So that means that the formulas we will need will be our normal circle formulas divided by 12. Let's go ahead and do that. The formula for this arc will be the formula for the circumference of a circle, 2 pi r, over 12. That reduces to pi times r over 6. The formula for the area of this sector will be the formula for the area of a circle, pi r squared, over 12. Let's plug in the numbers. Pi times the radius over 6 is pi times 4 inches over 6. 4 over 6 reduces to 2/3. If we were told to use 22 over 7 or 3.14 as an estimate of pi, we would now multiply that estimate by 2/3. But the problem says leave pi as pi, so our answer for the length of the arc is 2/3 pi inches. Now let's find the area of the sector. Pi times r squared over 12. R squared is 16 square inches. 16 over 12 reduces to 4 over 3. Leaving pi as pi gives us 4/3 pi inches squared. We're done! Now it's time to open your textbook. To complete this lesson, start by doing the example problems provided. Try to solve them on your own before you look at the solution and the steps. Once you think you have the correct answer, check your work by walking through the steps, making sure that you arrived at the solution the correct way. Once you are done, you're ready to move on to your homework. See you next time!